Hello and welcome to the start of the C3 program, and you're going to be looking at initially chapter 2 functions, and there's a lot in here, and it's a bit of a step up from some of the stuff we were doing in certainly C1 and C2. Right, so you can see on the board on the screen what's going to be looked at, and let's get cracking. So we're going to start off by looking at mappings, and it tells you here a mapping transforms one set of numbers into a different set of numbers. It can be described in words or by using an equation, and we can also sort of show a mapping on a graph. So starting off with example 1, it says draw mapping diagrams and graphs for the following operations. Add 3 on a set, minus 3, 1, 4 and 6, and then square on this set. So you can see just down here what we're talking about. The operation is add 3, the mapping diagram shown to the right here, just here. And what have we got? Well, if we're just adding 3, we go from minus 3 to 0, 1 to 4, 4 to 7, 6 to 9, and then x of course is x plus 3. Now this is the important information here. The important information is that the inputs, these values, or set A as they're called in this example, the inputs, their posh name is the domain. Okay, the domain is the values that go in, and the numbers that come out in set B are the range. Okay, so if we're thinking about this in terms of a graph, x is the value that we're putting in, and y is the value that's coming out, the x plus 3. So as you can see below, that's what they've done. They've got the graph, set A, these values here are the x values going in, and then we do the function, we add 3, so when x is 4, 4 goes in, 7 comes out, so that's plotted on the y-axis. So ultimately we're talking about some sort of quite basic stuff here. The domain are our input values, and the range is the output values. Okay. The second one is a squaring function. Again, domain, input values here, and range, output values. And the domain values, minus 1 and 1, both map onto 1. Minus 2 and 2 both map onto 4, and of course x maps onto x squared. And then we can see our graph, a typical quadratic curve at the bottom. Now, moving on. We now come on to the sort of quite important information, which is that a function is just a special mapping. Okay, so we've just looked at mappings. A function is purely a sort of a posh mapping, if you like, and it's where everything that is in the domain is mapped to exactly one element of the set B or the range. So that's sort of quite a difficult statement to get your head around, and these diagrams make life much easier. So if we have a function like at the bottom of the page here, like 2x plus 1, if we take inputs, say 3, 5 and 8, we double them and add 1 to them, so that's 6 plus 6 plus 1, so that's 7, 10 plus 1, so that's 11, 16 plus 1, so that's 17. Now, what we have here is a one-to-one function where we're taking a value and it maps onto one of the members of the range. What's important to note here is that we can frequently have functions where two different values will map onto a single value in the range. So, for example, if we were to look at y equals x squared, so if we've got 3 and minus 3, or 5 and minus 5, in both those cases we have a value, well, we have 9 and we have 25. Now this is a many-to-one function. Okay, a many-to-one function means we've got more than one value that maps onto one element of the range. What's important is that 3 just maps onto 9. It may well be that minus 9 does as well, but 3 doesn't map to anything else. That's what we're talking about when we say a one-to-one function or a many-to-one function. The members of the domain only map to one member of the range. Okay, whereas if we had a function that was something like square root, actually no, that's a terrible example, let's not use that. But ultimately, if we have something where we have a value or multiple values here, that when we do our operation we end up with the same value here, that would indicate that we're taking one value from the domain and it's mapping onto different values in the range. That is not a function. That cannot happen. Okay, so let's just have a look at a couple of examples in example 2. So it says, example 2, given that the function g of x equals 2x squared plus 3, find the value of when x is 2 ultimately, and the value of a such that g of a equals 35, and then we're going to talk about the range. So, first of all, this is all below in there, nicely laid out working actually, so we'll look at that. G of 2 here, so all we do is substitute in for x as 2. Okay, so g of 2, this is how we would write it, is 2 lots of 2 squared plus 3, so of course that's 2 lots of 4, that's 8 plus 3, so g of 2 is 11. Now, when the value of a such that g of a equals 35, so we're saying that this equals 35,